Examples on interpolation. Example number 1. If f of 75 equal to 246, f of 80 is equal to 202, f of 85 is equal to 118, and f of 90 is equal to 40, then find the value of f of 79. Now here you can observe that the values of x, that is 75, 80, 85 and 90 are equally spaced, and now we want to determine the value of f at x is equal to 79, very close to initial value, starting initial value, and therefore we are going to apply the Newton forward interpolation formula. So the step first, forward difference table, and by using this table we are going to determine the value of f at x is equal to 79. So 1, since 4 values are given, 2, 3 and 4, x and y. Say x is equal to 75, 80, 85, 90. The values of y equal to 246, then 202, 118 and 40. So the first forward difference is delta y is equal to 202 minus 246, so it is equal to minus 44. Now 118 minus 202 is minus 84. 40 minus 118 is equal to minus 78. Now delta square y, minus 84 minus 40 minus 44, so it is minus 40. Then minus 78 minus 84, so this is equal to 6. And last, delta cube y is equal to 6 minus 40 minus 40, so this is equal to 46. Now since we are going to apply the Newton forward interpolation formula, so this is the value, these values, these rows values we are going to use in the formula of Newton forward interpolation. So step number 2, here we are going to find the value of u, which is equal to x minus x0 divided by h, where x is the value at that point we want to determine f. So x is 79, x0 is the starting initial value of the table, that is 75, h is the difference between the values of x, so the difference is same, so which is 5, and therefore u is equal to 79 minus 75 divided by 5. This is equal to 4 divided by 5 is equal to 0.8. Now step number 3, so here u is equal to 0.8. Now step number 3, the Newton forward interpolation formula. Step number 3, the Newton forward interpolation formula is f of x is equal to y0 plus u delta y0 plus u into u minus 1 divided by 2 factorial delta square y0 plus u into u minus 1 u minus 2 divided by 3 factorial into delta cube y0. So now put all this value, f of x, that is f of 79, is equal to y0. So the y0 is the value at x0, so which is what, 246. This is 246, the value of y0. So this is 246 plus u is 0.8 delta y0. So what is delta y0? Minus 44 plus 0.8 into 0.8 minus 1 divided by 2 factorial is 2 into delta square y0. Now delta square y0 is minus 40, and last 0.8 into 0.8 minus 1, 0.8 minus 2 divided by 3 factorial is 6 into delta cube y0. By using table, delta cube y0 is what? 46. So it is equal to 46. So if you simplify this, f of 79 is equal to 246 minus 35.2 plus 3.2 plus 1.472, and therefore f of 79 is equal to 215.472. This is the value of 79. Now next, example number 2. The following data represent the function. Represent the function yx is equal to e raised to x, and the table given is x and y is 1.0, 1.5, 2.0 and 2.5. The values of corresponding values: 2.7183, 1.5 is 4.4817, 7.38 3891 and 12.1825. So find the value of f of 2. Find the value of y of 2.25 using Newton backward interpolation formula, and compare with exact value. So now we want to determine, again in the previous example we applied Newton forward interpolation formula. Here we want to use the Newton backward interpolation formula. So the first step is backward difference table. So the backward difference table is x, y, and so the given 4 values of x, 1, 2, 3, 4. So it is 1.0, 1.5, 2.0, 2.5. It is 2.7183, 4.48, 17, then 7.38, 891 and 12.1825. So delta y is equal to del y, no delta y. The first backward difference table is, first backward difference is equal to, now here 4.4817 minus 2.7183 is equal to, it is 1.7634, 7634. Then 7.78 minus 4.4817 is equal to 2.9074, and 12.1825 is minus 7.3891 is equal to 4.7934. Now the second difference is 2.90 minus 1.7634 is 1.144, and here the 4.7934 minus 2.9074 is equal to 1.886, and the third order difference is equal to the 1.886 minus 1.444 is equal to 0.742. So now here next step number 2. Now here we want to evaluate y of 2.25. It is very close to last value of x, that is 2.5. so here u is equal to x minus xn divided by h. So x is equal to here where x is equal to what x, we want to determine x at 2.25. X is what? 2.25. xn is 2.5. What is h here? You can see here the difference between h are 1.5 minus 1 point, or 2.0 minus 1.5, it is equal to 0.5. So u is equal to x minus xn, so it is 2.25 minus 2.5 divided by xn is equal to 0.5 is equal to minus 0.5. So u is equal to minus 0.5. Now the Newton step 3, the Newton backward interpolation formula is f of x is equal to yn plus u del yn plus u into u plus 1 divided by 2 factorial del square yn plus u into u plus 1 u plus 2 divided by 3 factorial into delta, here 3 factorial into del cube yn. So now if you substitute all this value where now in the backward difference table we are going to use these values here. So f of x, f of x is what? 2.25. so f of 2.25 is equal to yn. So what is yn here? This is xn 2.5, so yn is 12.1825. 12.1825 plus u is what? Minus 0.5 into del yn. So what is del yn? It is 4.7934. 4.7934 plus u is what? Minus 0.5 plus 1 divided by 2 factorial is 2 into del square yn. So what is del square yn? 1.886 plus u into minus 0.5 to minus 0.5 plus 1 minus 0.5 plus 2 divided by 3 factorial, that is 6 into del cube yn. So what is del cube yn? It is 0.742. 0.742. So it is equal to, if we simplify this, we get f of 2.25 is equal to 12.1825 minus 2.3967 minus 0.2358 minus 0.0464, and therefore f of 2.5 is equal to f of 2.25 is equal to 9.5037. So this is the value of y at x is equal to 2.25 using Newton backward interpolation formula. Now example number 3. Find the missing term of the following data. Find missing term from the following data. So the data given is x, y, 1989, then 1990, 1991, 1992, and 1993. And x, y is 443384. This is the missing term 397 and 467. Now we want to determine the missing term for the given data, from the given data. Now here you can see how many values are given. 4 values. This is the first value, this is second value, third value, and 4 values are given, and therefore now since 4 given 4 values of y, and hence the 4 values means what? This is the polynomial of degree 3. If n values are given, then we get a polynomial of degree n minus 1. Here 4 values are given means what? We get a polynomial of degree 3, and hence its fourth difference is equal to fourth difference of y is equal to what? 0. Fourth difference is 0. But what is the we know the relation between delta, the forward difference, and shifting operator. It is equal to e minus 1. So this is equal to e minus 1 raised to 4 y is equal to 0, or y0 is equal to 0. Okay, so this is equal to e minus 1. If we simplify this, it is equal to e raised to 4 minus 4e cube by using, that is 4c0. If we use here 4c0 e raised to 4 minus 1 raised to 0 plus 4c1 e raised to 3 minus 1 raised to 2 plus 4c2 e raised to 2 minus 1 raised to 3, then 432, then 4c3 e minus 1 raised to 4, and last e4 0 1 here 1, this is 2, this is 3, and 4c4 e raised to 0 minus 1 raised to what? 4 into y0 equal to 0. So now 4c0 is 1, 4c1 is 4. So this is what the first term is, e raised to 4. Then the second term is 4 minus 4e cube. 4c1 is 4. 4c2 is 4 factorial divided by 2 factorial into 2 factorial, so it is equal to 24 divided by 6, so it is equal to 6. So 6e square minus 1 raised to 2 is positive, minus 4c3 again 4, so this is 4e. Then next the 4c4 is 1, so 1 into y0 is equal to 0. Then, or you can write here f of x also. So now instead of y you can use f of x also. So this is equal to e raised to 4. If you multiply y0 inside the bracket, y0 minus 4e raised to 3 y0 plus 6e raised to 2 y0 minus 4 e into y0 plus y0 equal to 0. Now e raised to 4, we know that e raised to n y0 is equal to y of 0 plus nh. So h is what here? H is 1. You can see here the 189, 190, 91. So h is what? 1 here. So it is y0 plus 4. So it is y4 plus y4 minus 4y cube plus 6 is y2 minus 4y1 here e raised to 1 plus y0 equal to 0. Now y4, so this is what? y0, y1, y2, y3 and y4. So if you substitute this value here, we get y4 is equal to 467 minus 4 into y3 is 397 plus 6y2 we want to determine minus 4y1 is 384 and y0 is equal to 443. By using this data, say here y4 is 467, y3 is 397, y1 is 384, y0 is 443 and y2, the value of y2 want to determine. So if we simplify this, we get the 6y2 is equal minus 2214 equal to 0, and therefore y2 is equal to 2214 divided by 6, which is equal to 369. So the value of y2 is equal to 369. The next example number 4, last example. Here, find the polynomial using Lagrange's interpolation formula. Find polynomial using Lagrange's interpolation formula. This interpolation formula. There is one missing in the example number 2. One step is missing. In example number 2, we want to compare with exact value. That is, what is the e raised to 2.25? Here we have calculated. Calculated value is what? 9.5037. So e raised to 2.25 is equal to, once minute, e raised to 2.25 is equal to 9.4877. So here there is error between exact value. This is the exact value. You just find the error between exact value and absolute value, so you will get the difference between the comparison between actual value and approximate value. Now in the last example, find the polynomial using Lagrange's interpolation formula for the given following data. The data is 0, 1, 2, 3, x is equal to 0, 1, 2, 3 and y is equal to 1, 4, 13, 34. So this data is given, and by using this data we want to determine the Lagrange's interpolation formula. So here this is the value of x0, x1, x2, x3. This is y0 or y0, y1, y2, y3. So the Lagrange's polynomial calculated by using the formula f of x is equal to x minus x1, x minus x2, x minus x3 divided by x0 minus x1, x0 minus x2, x0 minus x3 into y0 plus x minus x0, x minus x2, x minus x3 divided by x1 minus x0, x1 minus x2, x1 minus x3 into y1 plus the third value is x minus x0, x minus x1, x minus x3 divided by x1, x2 minus x0, x2 minus x1, x2 minus x3 y2 plus last term x minus x0, x minus x1, x minus x2 divided by x3 minus x0, x3 minus x1, x3 minus x2 into y3. So now if you substitute all these values x0, x1, x2, x3, y0, then we get f of x is equal to x minus x1. What is the first? X minus x1. The x minus x1 is what? X minus 1, x minus 1, x minus 2, x minus 3 divided by x0, that is 0 minus 1, 0 minus 2, 0 minus 3 into y0, that is 1 plus now x minus x0, that is x minus 0, x minus 2, x minus 3 divided by 1 minus 0, 1 minus 2, 1 minus 3 into y1, that is 4 plus now x minus 0, x minus 1, x minus 3 divided by the 2 minus 0, 2 minus 1, 2 minus 3 into y1, y2, that is 13 plus x minus 0, x minus 1, x minus 2 divided by here it is equal to 3 minus 0, 3 minus 1 and 3 minus 2 into 34. So now if you simplify this, if you simplify x minus 1, x minus 2 into x minus 3, then we get f of x is equal to x cube minus 6x square plus 11x minus 6 divided by minus 1 into minus 2 into minus 3. So this is equal to minus 6 plus x cube minus 5x square plus 6x divided by 2 into 4, that is, this is 2. 1 minus 0 is 1, 1 minus 2 is minus 1, and 1 minus 3 is minus 2. So minus 2 into minus 1 is 2 into y1 is equal to what? 4. The next term is x cube minus 4x square plus thrice x divided by minus 2 into 13 plus last term is x cube minus 3x square plus twice x divided by 6 into 34. So now again if we simplify this, f of x is equal to x cube. Here if you simplify this, if we simplify and take LCM here, then again this denominator of this two term is same here, this two term, and denominator of this two term is same, instead of only a minus sign is there. So here if you simplify, it is equal to, and then we get the final answer is what, x cube plus twice x plus 1. So this is the polynomial using Lagrange's interpolation formula.